Okay, this video is going to be a continuation of our last topic, which was data stores. Last time we built a quick little program, scores, and basically the program kept track of different scores you might have in a classroom type setting. We created this scores.dat file. It's sort of a generic extension for a file that contains data, and we structured the data as one score per line. And then using our Python program, scores.py, we created a little menu that allowed you to add a score, and then after you added a score, it would be saved in this DAT file. So you could close the program and you would still have your data available to you when you ran the program again. Okay? So this is a file store. We're using the file for long-term storage. So after the computer program stops running, the data when the computer program is running, all the data is stored in memory. Memory is volatile, right? If we want it to persist, we have to store this data into a file. Okay, so we get persistent storage with a data store. Now this data store is a very simple one. It's just a file. Not all data stores are just files, but this particular one is a file. It's one of the simplest ones you can have. All right, so what we want to do this time is look how we might go about the same type of problem, but instead of having one collection of data, now if you remember from last time, this collection of data is homogeneous, right? There is one type of data and it just repeats, right? So these are all quiz scores or some type of score, and you can expect the data to be between 0 and 100, right? It's homogeneous. Now, what we want to do is potentially have the records of scores for different students, right? So we have to think about how we want to structure our file. And this is entirely up to us. We could do it any type of way that we want. One fairly straightforward way of doing this might be to start on each line we would have the scores, right? But we would have to have some way of separating them. Right, so we would want maybe a name, Alice, and right, and we could just separate them with spaces, right? So anytime you have a space, this would be considered a new field, and that would be fine, unless of course we wanted to consider this name to be one field, in which case it has a space in it, and that could be problematic. Right, we might have fields that have spaces in them. All right, so a common format that might be used is what's called a CSV file, comma separated values, where each of these fields is separated by commas. So this would be the full name field, or if I wanted separate fields, I could place a comma there, and this would be the first name field, last name, and then scores. And so the next line could have I'm just making up names here. So Bob Berry, we can get rid of that space, and then you can have just making up some scores here, and no space there. 88. Right, so now we have this concept of multiple individuals, right? So across a row of our data, this could be thought of as an object. In terms of databases and data stores, this is often referred to as a record. This is one individual record, and this table is supposed to represent students and their test scores. So these two fields together identify the student, and then the remaining fields are their scores, right? And this is all well and fine. We could continue to add data here. This could be, or we'll do Carly and again, I'm just making up some names here. So add some data. Alright, so they got 3 quiz scores here. Alice Allison, Bob Berry, and Carly Carson. Right? Now this is all fine until we get to a situation where we might have two people with the same name. Right? And so then we're going to need some other special way to uniquely identify these people. All right? But let's not get ahead of ourselves. This is our new file format, scores.dat, right? And we're still keeping track of scores, but you see now this list is homogeneous as we go down. So every one of these records is the same format. We have a first name, a last name, and then 3 scores. First name, last name, 3 scores, right? So it's homogeneous going down, but it's heterogeneous going across. So here we have a first name, second name, and then a bunch of quiz scores. After this point, it's homogeneous, right? But the entire record is not. Okay, and this is common for most databases. There'll be an idea of a table, and all of the information in the table is organized by record types. So how do we define what a record is? Well, in this case, this is going to be a first name, last name, and then 3 scores, right? And then each of those records are homogeneous in the sense that all of them contain the first name, last name, and then 3 scores. Okay, so this is fairly standard setup. So what we're going to try to do, let me select all this and copy it. I'm going to copy this to a new file. We'll get back to our old file there, so we don't lose our scores.dat. We're going to make a new file, and this is going to be our scores.csv. Okay, CSV is a type of file format. Has lots of different options, but the main idea is that it's comma separated values. So that's exactly what we're doing here. In each record, we are separating the values by commas, so CSV, right? And at the end of the line, we're separating records with new lines, just like we did in our other list in scores.dat. All right. So what we want to do is make a new version of scores.py. So this is going to be, we'll call it CSV scores. And the first thing we might want to do is try to grab the data from the file and then parse it. And by parse it, I mean form some sort of data structure to hold the data in the program. Right now the data is just in the file, but we're used to holding it in the program in some sort of form. It could be a dictionary, it could be a list. There's a number of different ways you can hold data in the program itself. So we're going to parse this data, and all that means is we're going to look inside of scores.cvs, take that raw data, and structure it in some way into our program. Okay, so that's all parsing really is. All right, so let's start by opening the file and reading it in. Okay, so our file name is scores.csv, comma separated values, and we want to read this data in. And we get some data, and we'll say file.read, and then file.close. All right, so this is going to be a simple program to start with. We can print out the data now. So our program will read this file, and then to start with, we'll just print it out. Let me open my terminal, and I can run Python 3 CSV scores. Right, and it prints out that data. And actually, let's change this to parse CSV, or change the name. I think that's a better name. Sorry about that. Just so there's no confusion with the other scores. CSV, or parse CSV. All right, we'll change that name, change this, parse CSV. All right, so we run the program again. This is parse CSV, and that's wrong. It needs to go back to scores. There we go. Parse CSV, and all right, prints out the information. Okay, so all I did was I changed the name there. So now we have this data stored in the file data. What we want to do is we want to store it in some sort of structured list, right? So if we used a dictionary, we would want to have the key name, we would want to reference maybe a student, and then have access to a list of items, right? So to reference a student, it would be very common for them to have the same last name or the same first name. So we're probably going to want to use both their first and last name as a key, right? But even then we can run into some problems, and we'll show that next. But for this, we're going to want to maybe keep a dictionary of students and then a list of their associated scores. Okay, so this will be student scores. All right, and we're going to make an empty dictionary. And we don't need to print out the data. We already did that. So what I want to do is I want to do something to this data that turns it into something useful, right? So one of the common things we do is we split it over the new line character, right? We could do that with a loop manually. Whenever we see a new line character, then add everything up to that point into a list. But Python has a built-in way of doing this. So we can just say data.split, and it splits the data over the character you provide. So I'm providing the new line character. So whenever it sees, so remember data just holds the string data that's in our scores.csv file. So whenever we split over the new line character, so there's a new line character there, that means all of this will be the first item in the list, and then all of this will be the second item in the list, and then all of this will be the third item in the list. And because there's an additional new line character here, there will probably be an empty string at the end. Okay, so essentially what happens is the new line characters are the delimiters. They are removed, and everything from the beginning of the list to the delimiter, or from delimiter to delimiter, is added to a list. Right? So since we have a delimiter here at the end and nothing afterwards, then the empty string is going to be added at the end. Right? So we can call this lines because that's an appropriate name, lines of our CSV file. And be careful with your naming. And we'll print out lines to see what we have here. Okay, and it looks like that's correct, right? Each one of these lines, and then we have this extra empty string at the end, which we don't want. Okay, so we could just remove that manually, but we could also, whenever we get this data, we could call dot strip, and that strips off any white space from the beginning or end of the string. Okay, now it won't, if we had something like spaces in between, it wouldn't take care of that. But specifically from the very beginning of the data and the very end of the data, it strips off white space. So what we're looking for is for it to strip off this new line character. Then when we use the split, there's only these two new line characters, right? Which will mean we'll have the 3 lines in a list. Okay, so that's what .strip does. And we're doing this right after we read the file, right? So file.read, that's going to be the string data, and then .strip, that's going to convert that string, or remove the leading and trailing white space from that string data, and then all of that will be stored in data. Okay, so then I don't have to change anything down here, and we should get a good list. Okay, so notice that empty string there is not in this list. Okay, good. So the next thing, one thing we also might want to do is, in case you're using Windows, if we're splitting over the new line character, Windows tends to have a carriage return character as well. So if you look at the line endings here for this file, it's Unix line endings. It's the line feed, which is the new line character. You might see CRLF if you're using Windows. So CR is the carriage return, and it's a \r when you put it in a string literal. So I want to remove those, so that way when there's not an extra character at the end of these strings. So in case somebody's using Windows, it's just whenever you read a file, it's a good practice to go ahead and strip off the leading and trailing white space, and then .replace. We want to replace all of the instances of \r, the carriage return, and we'll replace them with nothing. Okay, so that just removes all of the carriage returns. All right, it's a quick little shortcut. So this is common on any data file you have. You might read it, strip off the data at the beginning and end, and then replace carriage returns with nothing, and now we're guaranteed to have reasonably consistent data. All right, so we split this into the new line character. Split this data over the new line character into lines, right? And we run this one more time just to be sure we didn't break anything. Yep, we're good to go. All right, so now that I have lines, what do I need to do? Well, each one of those lines, I need to parse that out, right? So I might do a for loop for line in lines, right? And the first name is going to be line. So line is just a string, right? So I can't reference any items in it. It would be really nice if line was a list, and I could say line at index 0, you know, would be Alice's first name. Line index 1 would be the last name, right? It'd be nice if I could do something like that. But line at this point is just a string, right? So maybe we call this string for s in lines, and then we'll call line s.split, and we're going to split this over the comma. So that means the comma is the delimiter, right? So in this case, now we're inside of a for loop, right? So this first time through the list, we're talking about this string. Next time through the list, we'll be talking about that one, and finally, we'll be talking about this one. So in this first time through the for loop, if we split over the comma character, that means this will be in our list, Alice, then Allison will be in our list next, then these scores. None of the commas will be in our list. They are the delimiters. They separate the items in our list. Okay, so I can test this out, and I can print out each one of these now. So previously I printed out the lines, and we saw that those are strings, right? This is a list of strings. Now, for each item in our list, right, for each string in our list lines, we're going to make another list called line, right? And I'm going to remove this print. And so we should just print out each one of those lines. And this should be a list of those individual fields. Right? Sure enough, we now have a list, and Alice is a string, and that's the first item of our list. Allison is a string, and that's the second item, right? Now all of these scores are strings too, and we're going to have to convert those at some point. All right, so what we can do here is we can say, now that we have a list, we can say, we don't need to print that out anymore, but we have the first name, and that's going to be line. That's our list, the item at index 0. Then we have last name, and that's our list line, the item at index 1. And then we might want to make a list of scores. All right? So for the rest of the items, so for item in line, but we don't want the first and last name. We've already taken care of those. So we're going to take a slice and go from item 2 to the end. Okay, this is going to basically, if this is slice 0, think of it like the whole thing is a loaf of bread. This is slice 0, slice 1, and slice 2. So I'm going to go from slice 2 to the end. So that's what this syntax does down here. It takes the list from slice 2, and if you leave this blank, the assumption is it goes to the end. So whenever you see this colon syntax inside of square brackets, that's called taking a slice. Right? So in this syntax, for each item in our list, right, our list now is always going to be the scores. And even if we add more scores, it'll still be the scores in our list, right? So we can say scores dot append, and we could just add the item, right? But that wouldn't be very useful, because then, you know, this list would basically be the same thing. What we want to do is we want to change this item, because it's a string. We need to convert it into a float. And that for loop will iterate over each one of those string-based scores and convert them to a float and store them in this list called scores. So now we have three main variables we're dealing with that refer to one of these individuals in our list. Right? We have a first name, a last name, and scores. So I can just print this out real quick. Print last, comma, first, colon, and then scores. All right. So this is sort of the style of the data structure we want. We want our student scores dictionary to have, right? So the keys to this dictionary might be the last name, comma, first name, and then the value of that dictionary will just be this list of values. Okay, so we can say student scores, and here we're setting a value, so we have to specify the key. Well, I want the key to be the last name, comma, space, and then the first name. So that's the key to my dictionary, and I want the value to be the scores list. All right. So now we've successfully parsed the data from the file into student scores. Okay, and we can look at this, we can print this out directly, student scores. Right, you can see that. There's also a nice feature you can, from the pretty print package, you can import the pretty print function, and then instead of printing, you can pretty print, and this helps you printing out lists and dictionaries. So you see how this dictionary is just one big line. If you use pretty print, you can see it does one line at a time, right? And you can see your data a little bit easier. Okay, so that's parsing data from a CSV file. Now in the next video we're going to discuss how we can, add things to this. How would we add values to the end, right? We'll basically want to add something to this student scores data structure, right? So whenever we get data from the file, we want to create this data structure, create this student scores. Then we can manipulate the student scores, and we eventually have to have some way of going back to the file, right? So back to the CSV file. So that's core to the concept of any data store. You have to retrieve the data from whatever methodology you're using to store that data, and you have to translate it into some useful data structure in your program, right? And to go the other way, if you actually want to save the data, you go from your data structure to, in this case, string data, and we just save that string data to a file. Okay, so this first method is going one way, and well, let's just do that. We'll make one modification to each one of these values. We'll add a score for each one of the students. So this will be add score for each student in student scores. Right, so student here, student scores is a dictionary, so we need to say dot keys. So this is going to be a list, and this is going to be the student name. So for each student name in the list of keys to this dictionary, so remember the keys of our dictionary are just the last comma first name, right? So the scores are the score is going to equal, the list of scores will equal the dictionary, student scores, and then access the item at this key. Right, so that's the scores. and we'll say scores.append, and we're going to add the same score for everybody. We'll say that's a good score, 92, something like that. So everyone is going to have this new score at the end. Now this is, again, we're just manipulating this data structure in memory. It's the program data structure. We're not storing it to the file yet, right? So when we run this program, now all three of them got 92s. Very suspicious, right? Okay, so we've changed this data structure, and now we want to save it back, right? So everything we did up here, this was loading, right? This was loading the data from the file and parsing it to a data structure. So this we could probably put into a function. We could call this load data, right? And then down here we're going to save the data, right? And we could also put this into a function, right? So this is load data, and this is save data. So to save data, what we want to do is the inverse of everything we did up here, right? So the opposite of the split function, right? The opposite of that is the join function, and you can join things into a list. All right, so for to save the data, for name in student scores keys, the scores are this list, scores, and then the name. Now we want to turn all of those back into string data, right? This is the way we did that last time. We had to convert all the string data to float data, right? So we could use a similar technique. We would make a for loop for, first we make string scores. This is our list of string scores for score in scores. So score is an individual floating point decimal. We're going to say string scores append, and we want the string version of that. All right, so now we have a list of string scores. And then we need to split up name. So name.split. We're going to split that over the comma space. So comma space is what we used in our key. Right, comma space. So this name value here is this entire key, right? The name is in our dictionary keys, right? So name is the entire thing. If we split that over comma space, then that's going to give us a list where the last item, or the first item, index 0, is the last name, and then the second item, index 1, is the first name, right? So this is going to be give us a list. We'll just call it li right now, sort of a generic variable name for a list. And to make the entire line, we want basically to have line equal, and Python allows you to join lists together with the plus operator. Okay, so we can say the item in li at index 1, that's the first name, right? And we want to have the item at index 0 as the next item in our list, right? So this is a list. This is going to be first name and last name. So the reason we have to do that is because that's the format of our original CSV file, right? We changed the format around a little bit. We could have made the dictionary keys Alice, Allison, and that might have been a little bit simpler, right? But all the time in computer science, you're going to have to massage the data and manipulate the data and convert it to different formats. Okay, so this is something that you should definitely get used to. All right, so we know that in our current name, it's last name, comma, space, first name. So this name variable. So that means when we split it to the list, the item at index 1 is the first name, and the item at index 0 is the last name. And then we want to add in all of the string scores. Okay, so this is where Python is nice because it allows you to combine two lists. This list added to this list. Okay, so that means we're going to get one big list where these two items are first and then the string scores are last. And then we can join all of those, right? This entire list, a string version of the line, is going to be, we want to join them with the comma dot join. What are we joining? This line, right? So all of the string values in this list are going to be joined with a comma, and then we'll have a string line. Okay, and so we'll make another variable called lines up here. This is string lines. String lines dot append string line. And then we can say data equals string lines. Now this is a list, right, of strings, and we want to join that together with the new line character. So again, we're doing just the opposite of what we did when we parsed the data. Right, we parsed this data here, and then everything we did up there, we're doing just the opposite. And we can print out the data to see if it worked, see if we have any issues. Right, so we print that out and it works. You see we've got the 92 scores at the end. The last thing we need to do is write this to a file. So we could say file equals open. We want to open the file. The file name is scores.csv. We want to open it for writing. Right? And then file.write. What are we writing? We're writing the data. And then file.close. Get rid of that print statement. All right. Now again, this should all probably go in a function, because within a program you might need to save lots of times. Different points in the program you save your data, and then you might need to load. You might give the user an option to load a different file, for example. Okay, so let's take a look at scores.csv, and it just has these 3 scores. So once we do this, once we run this, we should see 92 scores on each one of these. And I should be able to run the program again, and it would add another set of 92s for all users. All right, so let's run this. Okay, so we'll look, and sure enough, we have an extra set of 92s. Okay, so we successfully saved our data. And if I run it again, we have 2 more scores of 92. Okay, so hopefully this demonstrates how you can load data from a CSV file, and each line of that file should represent one object. It's commonly referred to as a record. And we can modify those records, adding quiz scores, right, and still save data back into the data store. Okay, so this is somewhat unusual. This is a dynamic data store where the values that you can have in each record are dynamic. We can change that. Normally in most tables and most databases, the record types, right, that's called a schema, and the schema is usually set. Now you can do operations to change the schema, but that has various impacts, right, on performance and different things. So so this is a very, very basic example of a data store that's starting to sort of feel like a database, right? This is just a file store, but it has similarities to a database in that we have a table of data. Each line is a record of data. It represents one object, and then the columns of that data share attributes, right? So the column here, this is all first name. These are all last name, right? And we did this all with files using delimiters or separators. So the delimiters between records are the new line characters, and then the delimiters between the fields are the commas. So again, that's why this is called a CSV, comma separated values. And this is a very, very common format for simple tables of data.